Sideboard again. Fun Sock Friday, the most lit day of the week. Last Fun Sock Friday for you guys for the school year. And 7th of May, you guys will be able to find and interpret measurements of central tendency. Section 12.3. Now, central means middle. Tendency means what is often to happen, okay? Olivia, put it away. Thank you. So measure of central tendency is a value that describes the center, Aiden, write it down, / middle of data. Olivia, write it down, please. Thank you. I think we're like one more page past that.
Oh my gosh.
Yeah.
It doesn't have the section names. I'm looking for
Oh, yeah. That's true. Did you find it now?
Yeah.
The first type of measure of central tendency we're going to talk about is the mean. The mean is going to be like a U, but with a little tail in the front. So you see how I did that? I made a U and a little tail in the front. Howdy.
That's not like an M.
It looks like an M.
It's a U.
You can kind of see it as an M, like
No.
as if I didn't go all the way on that second tail. Like it kind of be an M. Mean is going to be defined as the average. Does anyone know how you find the mean of something? Tucker.
You add everything up and divide it by how many there is.
Couldn't have said it better myself. Add everything up, divide by however many there are. The median, where have you guys seen the word median before in real life?
The middle of the road.
The middle of the road, right? Now, do all roads have median?
No.
No, but some roads do, especially highways, right?
Yeah.
And the median separates the two sides of the road, right?
Yeah.
It's the middle of it. So median is going to be, get ready for this, the middle value.
Wow.
Does that kind of relate?
Yeah.
Okay. I hope that makes it a little easier for you to remember that one.
It's like kindergarten stuff. Like. No,
This is like-
fifth
like
grade
eighth
stuff.
grade.
Mode or modes.
Fifth
There can be multiple. Guys.
I never learned this in 8th grade.
Shush, shush, shush. Thank you. The most
New to me.
repeated value. It's what do you see most often? So we're going to practice finding the mean, median, mode for each data set. Ms. Hassel, could I actually have you pass out some calculators to people? Thank you so much. Now, while Ms. Hassel's passing out the calculators, we're going to talk about what we're going to do on number 1. We have these data points. And how many data points do we have? 9. So to find the mean, we're going to find out the sum. We're going to add up all of these and divide it by what?
9.
9. So go ahead and figure out what goes on top of that fraction. Go ahead and add all these together and don't blur it.
I'm coming here.
Wait, what did you say?
Go ahead and add up all of these numbers and put it over 9. Don't blur it though.
Add them up.
Mm-hmm.
Like multiplication or addition.
Addition, yep. All right, what did we get on top of that fraction? Oh,
I'm not done either.
I'm not done yet. I'm not done either. Mr. Dawson, it's me. All right, if you're still going, keep finishing up. Tucker, what'd you get?
471.
I would agree. If you didn't get 471, I would suggest that you probably did that wrong. All right. So the mean is going to be whatever we get by dividing that. And let's just say what it ends up being. Okay, go ahead.
52.3
52.3 repeating. So we're going to put that little bar over the 3 because that means repeating, right?
Yeah.
Okay. Thank you, Hannah. So, now, in order to find the median and mode, what's going to be easiest for us to do? Does anyone know?
Find value.
Wait, hang on. Oh, the repeated stuff.
Okay. But in order to find them, something's going to help us. And it's going to be putting them in a certain order. Least to greatest. So what's going to be the lowest number?
35.
35. Now, here's a tip, guys. Something I found to really help, okay? Miss Hazel will probably agree with this, I'm guessing. Once I write down 35, I'm going to cross out the 35 above. That way, do I have to worry about it anymore?
No.
Okay? So then, I can even just visually know I can ignore it. So what's my next number? 46. Cross it out. Now, I know my next number is going to be in the 50s. What is it?
51.
Which one of them? Both. You're right, both. 51, 51. Cross them both out. What's next? 53. What's next? 58. What's next? 58. The other one.
59.
And then 59. And now you already know you only have one left, and it's 60. So does crossing them out kind of help you figure out what still has to come? Yeah. Because every time you do one more, it gets easier and easier and easier. Aiden, isn't that right? Yeah, thanks for writing those down. All right. So, the median is going to be whatever's in the dead center. So what's in the center left to right? Just like in the road, what's in the center left to right? The median.
53.
In this case, it is 53. The mode, what do we see most common?
Both 58 and 51.
Both 58 and 51. So I'll put 51, comma, 58. Because they're both seen an equal amount of times. Yes?
Okay, so do we have to put it in least to greatest? Can we just...
For the median?
Yeah.
For the median, if we just went originally, 46 would have been in the middle.
Yeah.
But is that actually in the middle of the data? No. So we need to have it left to right, least to greatest, in order to find the median well.
Dang.
Otherwise, you'd have to try and poke out through it. So it's going to be much easier if you spend the time just to rearrange it real quick and then go. Yep. Great question. Any other questions on that?
No.
I want you guys to try number 2 on your own. Thank you. All right. So for the mean, we add them all up, and like Hannah just told me, we get 228 over 12. And we end up getting what, Hannah?
19.
19. The median, let's order them from least to greatest. Once again, I suggest slashing these out, okay? So the order ends up being 7, 10, 11, 15, 15, 19. 21, 24, haha. 24, haha. 24, haha. 27. There you go. And 31. Ooh. Now, median, there's actually 2 numbers in the middle. We happen to see both 19 and 20 be exactly in the middle. They both have 5 on each side of them. So we go halfway between them. Now, with 19 and 21, it's pretty easy to go halfway between them, right? Because they're only 2 numbers apart, and so we can say pretty confidently it's 20. But what if the numbers are farther apart? What could we do, mathematically speaking? Well, what you would do is you would say 19 plus 21, add the 2 numbers, and divide by 2. That'll give you the average between them. Just like how average, you add all the numbers up, divide by however many things there are, add the 2, divide by the 2. And you end up getting 40 divided by 2, which was 20.
This is so easy.
Good. Olivia, mask over your nose, please.
Can I go to the restroom?
Thank you. Yes. The mode, what is the number you see the absolute most of?
24.
24, uh-huh. Now, you also see 15 a couple times, but is it as many times as 24, huh? No, so there's just one mode this time.
Okay, so in 5th grade, our math teacher, Miss Johnson, he explained it so weirdly. Ever since then, I had not been able to grasp the concept, but now you're finally explaining it the way you should have explained it, the first time.
I'm happy it's making sense now.
It was so cool to know.
All right.
So positive.
Measures of variation. Variation is just how far something is from the norm. Variation, how much does it vary? Okay, how much does it differ? Okay, let's go. Thank you. So, it's scary. Okay, measures of variation. It is a value that describes how spread out a set of data is. Let's say, for example, Mason, put it away. Thank you. Let's say, for example, I got hired by a restaurant that is trying out a new sandwich. And they say, hey, Mr. Kossel, I hear you're pretty decent with numbers. And I said, yeah, sometimes. And they're like, okay, can you figure out how well people like this new sandwich? Okay, so I sent out some surveys, I collect some data, and let's say one of the questions was a scale of 1 to 10 of how much you like the sandwich. Now let's say the average of that was pretty high. Let's say it was about 8. Okay, so you would say that, yeah, most people like the sandwich pretty well, right? Okay, now what if though, would it be important to know?
Is that a set?
Set.
Oh.
Would it be important to know whether or not most people really were right around the 8 mark, or whether or not, well, there were quite a few 10s, there were quite a few 6s that were kind of on the border of it, there were even some 3s and 4s, but it settled around an 8. Are those two things different?
Yeah.
Yeah, the restaurant would probably care about that, because if there's quite a few 5s and 6s in there, if you would rate something at about a 5 or a 6, are you likely to order that same thing again?
No.
Probably not. You'd probably get something else. But if you call it closer to that 8 or 9, are you probably going to get it more often? Yeah. So, depending on how far spread out that data is, that might tell the restaurant how successful that item was, isn't it? So sometimes just the normal mean, median, and mode isn't enough for what we want to do. Sometimes we want to know other things, okay? It can be more helpful to us. The mean absolute deviation is one of these ways that we can measure it. We have some different ways to measure it. And Tucker said, this formula kind of looks scary. And it does. Okay? Okay. Now, it's actually not as scary as it looks, though, I'll be honest with you, okay? Now, we're going to define mean absolute deviation as the average, and everything's up and dividing, the average distance, how far something is, of each value to the mean. We're going to say, hey, how far is each piece of data from the mean? And then we're going to average that together. So the first thing we need to do is find the mean. So let's add up these numbers, divide by however many they are, and find the mean in example 3. Go ahead and do that. Find the mean.
What did you say we're doing?
Finding the mean of number 3 real quick.
You said we had to add them up.
Well, you're finding the mean, so how do you find the mean?
Count it. Middle.
No. That's median.
Oh.
Median means middle.
Oh.
How do you find the mean?
You add them all
And do what?
up. Count. 1, 2. Divide.
Divide by how many?
6. However there are.
However many there are.
Look at the bottom numbers.
Okay, let's go to 2 decimal places. Okay, go to divide by however many you should.
I did.
79.8.
2 decimal places.
Oh, 2 decimal places? 79.83.
I would agree with that. If you don't get 79.83, I would suggest that maybe you typed it in wrong.
So, that's the answer?
That's the mean. That's part of our
yeah.
answer.
First step.
That's our first step.
Oh.
Don't act like that was hard. Adding and dividing. Are you kidding me? But use the calculator. Just punch some buttons. Oh, are you kidding me? Yeah, you're fine. Okay? Now, this big fancy thing just means sum. Means you're adding things up. You're adding up each data point subtracted by the mean. And you're taking the absolute value. What's absolute value going to do to anything that's negative? What does absolute value do to anything that's negative? Makes it positive. It wants to do to positive things. Nope.
Keep it positive.
Keep it positive. Does nothing. And we're going to divide by however many things there are. So what's the first piece of data we see?
That.
Nope.
Oh.
What's the first piece of data we have?
Me.
The point.
85 is our first piece of data. So we're going to take 85 minus 79.83. Put it in parentheses. Plus, what's our next piece of data? 74. Minus.
Where are you getting numbers?
Oh my god, we have to do.
Oh my
Okay,
God.
actually, see me. The first one's going to go in the first one is not going to go in parentheses. My bad. It's going to go in absolute value bars.
Are you going to subtract it all by 79.83?
Yep.
What? We gotta rid of all that?
Oh my gosh, poor you.
Oh no, we got
Okay. The next piece of data. What's the next data point we see after 74?
99.
88.
88. 88 minus 79.83.
I can do this in my head.
Okay. Plus, what's the next one?
Oh dear Lord.
He is, isn't he? Let's not say that in here, though.
That's a bad word.
Basically, just minusing it against everything.
Yeah, so what's the next one then? If we know what we're doing, 80.
I can do that on a calculator, can I?
I'll show you that in a moment, whether or not you can. On this one, actually, you can't really. Okay, what's the next one? 92 minus 79.83. So we're taking everything and subtracting the mean and doing absolute value. What's the last one?
60.
That's a lot of writing.
Yeah, it is.
For you. Hey, did I just write everything you did too, though?
Yeah.
Yeah. And fun fact, this is my third time teaching it today. So I've written this out 3 times. 4 times if you count my notes.
Oh my gosh.
So?
That's a lot of writing.
We're all in science.
He's not complaining though, you guys.
Thank you, Hannah. Hannah understood the point I was making. Thank you.
Yeah.
Now we're dividing
Okay.
everything by, let me make a better fraction bar. That was much better. By 5. Or not by 5, but by 6. Why 6?
There's 6 numbers.
There's 6 numbers, okay? So now let's do each of those subtractions. So it's 85 minus 79.83. You're typing it in your calculator. It's not hard.
It's 5.
Quit complaining, guys.
77.
5.17 plus, okay, the absolute value, thank you, of 74 minus 79.83. So do we care if it ends up being negative? No, we just say it's positive because it's absolute value.
Yay.
And what does that end up being? What's 74 minus 79.83?
Negative 5.83.
Okay, so it's 5.83 is what we're concerned about, the positive. Plus the next one, 88 minus 79.83. Type it in. Type it in. Type it in. Aiden. We're doing each of these problems. We did 85 minus 79.93, 74 minus 79.83, the absolute value. Now we're doing 88.
Would it be easier if it wasn't a decimal?
Sure, but it is. 8 point what?
17.
8.17
8.17.
plus 80 minus 79.83.
80 minus
0.17.
Zion, you need to at least write these down. Yep. 0.17 or 0.17 plus, now do next one, 92 minus 79.83.
12.17.
Okay. Then the last one, 60 minus 79.83. And do we care if it's negative?
No.
Nope, it's positive now because that's the value.
Puzzle, what comes after roughly 783.
1983.
19.83. We divide all those by 5. So we add all of it up. My goodness, I did that again. By 6. So we're taking the average of all of these. So what we did was we said, hey, this first piece of data, 85, it's 5.17 from the mean. Second one is 5.83 from the mean. The third is 8.17 from the mean, so on and so forth. And we're going to take the average of this.
It's 8.55.
And it actually rounds up, doesn't it?
Rounds it up, so that's 9.
Nope. Or if you went to 1,
Oh.
so we're going to 2 decimal places.
Right, sorry.
5130.
Yep, on the top you end up getting 51.34 divided by 6. And that gives us 8.56. So what this is saying... I'll wait a second for everyone to write this down. What this means, because you just found a number, but you don't know what it means right now. Let me tell you. This is saying, on average, these points of data, that's what they are, all points of data, are 8.56 away from the mean. Now, if our numbers were in the thousands, would 8.5 be very far from a number in the thousands, or would we say that's relatively close? If you're talking about numbers in the thousands,
Close. It's close.
that's pretty close. 8.5, that's not very far. Okay, that's pretty close. Now, when you're talking about numbers like this, though, is 8.5 a little bit farther away?
Yeah.
Yeah. Okay, so that's important to know because that could change depending on the numbers you have of how you interpret this. So a lot of statistics is not only being able to set up and use formulas and figure it out, it's actually being able to interpret it and say, okay, what does this mean in this context, in this situation? It could be different in another situation. Like I said, in another situation, it might be a big deal that is 8.56 away. In this situation, it might not be a big deal. We don't know. But either way, right now, it's decently far. All right, we're going to skip number 4.
Yeah.
No. No, we're sure about it. Yeah. I am. Okay. You know what? Here's what we're actually going to do right now. No. Okay. Variance. I should know how it is. Okay, variance. It kind of looks like a little O with like a visor on it. O with the visor on it, kind of. Okay? And it's squared.
Like a sideways 8.
Kind of like a sideways A, I suppose. Or sideways 9 if you want, or sideways Q, sideways 6, depending on the other way. Okay? Variance is another way to measure the variation. Hence variance, because it talks about varying. Variance is the average squared distance. Aiden. Thank you. The average squared distance of each value to the mean. If you look at this formula compared to the previous formula we just had, they're pretty similar, but a main difference is your data value minus your average is squared here. That's the main difference here, okay? And you might wonder, well, Mr. Costa, why are we bothering learning different things? Well, like we had with mode and median range, and mode, median, and mean, we found that, well, that might not always be the most useful thing. Sometimes we need to know other pieces of information too. So this is another tool, kind of in our tool belt, of saying this is also helpful to know, because sometimes you want this instead of the mean absolute deviation, the MAD. Okay? And sometimes we're going to want the standard deviation. Now, what's the difference between the variance and their standard deviation, do we notice? Yeah, this little symbol. What's this little symbol mean? The square root. Okay? And instead of being this O with the visor, or sideways A being squared, it's just normal. Because we square rooted it. Okay? So we're going to define standard deviation as the square root of variance, of the variance. And one note I want us to put on here is that standard deviation is often perceived or seen as the most useful measure of dispersion. Anyone know what dispersion means? Has anyone heard the word disperse? Okay, what does disperse mean? Being spread out, right? So dispersion, does it kind of seem similar to disperse?
I think it's the opposite, but I don't know.
Okay. It's actually not going to be the opposite. It's tied to it, though. Okay? It's tied to it. So a lot of times, if you see a word and it looks a lot like another word, it's pronounced a lot like another word, they're often going to be very similar. Okay, and that's the case here. Dispersion is just saying how much it is spread out. Okay? Disperse is like an act. Like saying, hey, spread out. Disperse. Dispersion is saying, well, how much did they spread out? So instead of the action saying, well, how much did it happen? Okay, it's like the noun. Does that make sense? Okay? So, it's just saying, it's a fancy way in math of saying spread out. Okay? So it's the most useful measure of how far things are spread out typically. Now, why do these numbers matter? Okay, well, we were just talking a little bit about that a moment ago, right? With variance. Okay, with the mean absolute deviation, the MAD. Okay? So one reason is a lower standard deviation indicates that the values, Mason, put it in your backpack. That the values are closer together. What do we think a higher standard deviation will mean then? Yeah, the values are, and it's however you want to say that. I'll say more spread out. If you want to say further apart, that's fine too. If you want to say more dispersed, you could. Okay? However you want to word that is fine. But the idea is the same, that the lower the standard deviation, the values are going to be closer. The higher, the farther apart they are, okay? Okay. We're going to find the variance and standard deviation for this first data set here, number 5 in our notes. So our first set is to still find the mean. But we found that the mean isn't actually too terribly hard to find, is it? Because we add these numbers up and we divide by... Nope. 5 here. You're doing what I did, Tucker. I'm rubbing off on you in a bad way. So somebody tell me what the mean ends up being, and it actually doesn't need to round this time.
Four. 433.
I think you still might need to divide, buddy.
Oh, yeah.
453.
460?
We need to make sure we're dividing by 5.
Oh, no.
Tucker.
I'm just asking
92.
that number.
So take it divided by 5, and if you get 92, you're right.
I got it.
If not, you made a mistake in typing it in. Okay, yes, Lainey. We are...
We are in what?
You got her?
Number. What do you mean? I get 92.
It's like halfway through your hand right now. Like where your finger is. It's right around there.
It's 5.
Yep.
Got it. Thanks, guys.
Okay. All right. Voices off again. So we add all those up, divide by 5, and we get 92. Now the variance is that little O with the visor squared. And what we're going to do mathematically here is we're going to still subtract each data value from the mean. So it's going to be, the first one is 85 minus 92. This time, instead of putting it in absolute value, though, here's what we're going to do. Okay, here's the difference. Put it in parentheses and square it. Then we move on to the next one. Plus, what's going to be our next parenthesis?
88 minus 92.
Very good.
Squared?
Yep, 88 minus 92 in parentheses, square it. Okay, and we're going to have how many of these parentheses? 5. One for each data set. Data value, excuse me. 91 minus 92, parentheses being squared. Next, 96 minus 92, parentheses being squared. Next, 100 minus 92, parentheses being squared. And what's all of this going to be divided by? 5, because there's 5 pieces of data. Now mathematically, at this point, we can just subtract. What is 85 minus 92? And what kind of 7 actually? Negative 7.
Negative 7.
Negative 7, it's in parentheses, and it'll be squared. Plus, the next one, 88 minus 92. 88 minus 92. Negative 4. In parentheses being squared. The next one, 91 minus 92. Negative 1 being squared. Plus, Aiden, you need to write this down. 96 minus 92.
2.
Nope.
4.
4 being squared. Love that you took a shot there. Next one, 100 minus 92. This is also the last one. 8 being squared. All over 5. Then we actually square these. What is negative 7 times itself? Negative 7 times negative 7.
What?
Negative 7 times negative 7. What's 7 times 7?
Negative 49.
What's a negative times a negative?
Positive.
Positive. So do we care that's a negative actually?
Nope.
It won't really matter. We're going to get 49. What's negative 4 times negative 4?
Positive.
Positive. And that's a positive.
5. Wait.
4 times 4.
Oh, 8.
You added them.
0.
Nope. 4 times 4. 16. Thank you, Lainey. Negative 1 times negative 1 is a positive. What's 1 times 1? 1.
2.
Next, 4 times 4. 4 squared. 16. Next, 8 times 8. 8 squared. 64. All over 5. Now, is any of the math we've done yet individually scary?
No.
Now, what could be scary is the fact that there's so many steps or so many numbers, right? Okay, but the math itself is math we can do. It's math we've done for a whole year now. We've been adding, subtracting, doing order of operations, squaring things, dividing things. We've been doing that for a while. Now, if you add these up and divide by 5,
94.8.
I don't think so. I think you might have had a typing error again. If you're noticing you're susceptible to more typing errors, it might be a good idea to try the problem twice to verify you get the same answer both times. If you don't, try it a third time to see which one's correct. That's what I do. Tucker.
I got 29.2.
I will agree with that one. 29.2. So we'll say the variance is 29.2. So once again, you take 49 plus 16 plus 1 plus 16 plus 64. Divide all of that by 5. Now, once you find the variance, how do we get the standard deviation? What do we say was the difference between variance and standard deviation? square root. Very good, Tucker. So, we're going to square root the standard deviation. Mr. Castle, how do I do that in my calculator? Great question. Hit the very top left button that says second.
Good job, Cass.
Right now, hit the very top left button that says second. Then, on the far left side, next to the 7, do you see an x squared button?
Yeah.
What do you see right above the x squared button, but not at the next button? You see the square root. Tap the x squared button.
Awesome.
Do you see the square root appear on your screen?
Yeah.
Yeah, you use second to get those little tiny ones in between the buttons. So it's second, x squared, and you get the square root. And then you type in 29.2 and hit enter, or equals. And what do you end up getting to one decimal place? 5.4. And that's the standard deviation. Whew, that was a lot of steps, wasn't it? Once again, was any of the individual math terrible?
No.
No, but it's a lot of steps. Now, next class, I will talk about a way that we can do this with the calculator that'll make our lives easier, okay? But I wanted you guys to see where it comes from first. And on our homework today, I'm actually not going to make you do the variance a long way either, okay?
Yay.
For now, before we finish up the notes, okay, so before next time we finish the notes, I want you to do numbers 1 and 2 entirely. And then for numbers 3 through 6, just do the mean absolute deviation. Just do the MAD, okay? The MAD was the first type of measures of variation we learned, okay? Don't do the variance or standard deviation yet, okay? We're going to wait till we learn the calculator way next time to do those, okay? That way I make your life a little easier, okay? And I know it says calculator instructions on those, but that won't work for this type of calculator that we use in here, okay? So it'll be different. Any questions on this, guys, on what the expectations are for next class? Okay? Now, real quick before you leave, okay, I want to say next week, the schedule. So next week, okay, and this will be for this class, but for my 8th period class, it'll be slightly different. So next week,
Your 8th grade.
I have this video goes out to both my 7th and 8th period classes because they're both Algebra 1Bs. So both are on different days. So the schedule looks different day-wise, but the pacing's the same. Okay, so next week on Troop and Tie Tuesday / Wednesday, when we wear pink for the 7th and 8th hour classes, we will be finishing up these notes, and then spending the rest of the time working on this homework, which shouldn't take terribly long since we get to use the calculator. And then we're gonna spend some time reviewing for a quiz over these things that we've learned. Okay, over these probability things. It's a quiz. Now, a quiz is different than a test. Okay, the quiz we'll be taking on the Throwback Thursday / Fun Sock Friday at the end of the week, our last day of regular class. We're gonna take the quiz to start. Then we're going to be spending the time reviewing for the final, which we'll be taking that following week during finals week, okay? Now that quiz, I want to talk about that. It's a giant homework grade. So it goes in smaller than a test, more than a homework, okay? So it's likely going to be the equivalent of a few homework assignments, okay? Does that make sense? Okay, so not as important as a test, a little more important than your homework, okay?
Yes, fine.